So you don't need to write any of these down, but these are just kind of a general overview of why a lot of people think that intelligence scores are important. So for better or for worse, intelligence scores are predictive of a lot of things. Things like school performance, your job performance, your likelihood of committing crimes, different life expectancies, political affiliation even, religious affiliation, how the nation is doing in its economy. Now, I want to again point out, these are correlations between these two things. So intelligence scores correlate with school performance, for instance. This is not causation. So if you remember back to our research methods lecture, correlation is not causation. So take some of these with a grain of salt because there could be a lot going on in these correlations. So let's get into how we actually attempt to measure it. And it's got some history to it. So formal intelligence testing began in about 1904. You had this guy, Alfred Binet and Theodore Simon, who were instructed by the French government to try to devise some objective assessment of school children so they could identify which children had intellectual disabilities and needed to be put in different classes. So they assumed, they were kind of thinking about this and how to best go about this, and they assumed that relatively bright children would behave cognitively like older children, while children who are less intelligent might behave more like younger children. So what they did is they devised items that would kind of indicate a child's what they called mental age. So we're going to talk about two different ages here. The first I have depicted, let's use these three women as an example. So chronological age is what we think about when we talk about our age. So this is how many years you've been on Earth. So let's say this girl's 12 years old, she's 15, and she's 18. So these are their chronological ages. The other age that Binet and Simon talked about was mental age. So this is what abilities you have relative to peers of that age group. So just to kind of mock you up a little example here, let's say that there are certain math abilities that people tend to progress to at certain ages. I'm a math nerd, so this is where my brain goes first. So let's say approximately by age 12, most people that age know algebra or learn algebra. Let's say by 15, you know geometry, and by 18, you know calculus. So this is like the average ability of people of that age group. So what we can do to figure out these three individuals' mental ages is comparing their abilities to what their peers are able to do. So for instance, maybe this first girl can do algebra and also geometry, but can't do calculus yet. So we would classify her mental age as 15 because she matches the abilities of 15-year-olds. Same with this girl, let's say she can also do calculus. Then even though her chronological age is 15, she would have a mental age of 18. In this example, there's a lot going into this, but just bear with me. And then similar here, let's say this student's right on track and they can do all three things expected of them, so their mental age is also 18 as well. So they kind of used this logic of mental age and chronological age to devise what we now call an intelligence quotient, or IQ. So this is a systematic means of trying to quantify difference in intelligence among people. And the first kind of scale that tried to get at this from those people, this is a guy kind of joined this squad who was from Stanford. His name was Lewis Terman. And he combined and made this kind of overall equation to represent IQ. And the way they did this is they divided someone's mental age, so their cognitive abilities relative to their peers, divided by their actual age on Earth. And then they multiplied by 100 to make it a number between like 70 and 160 or whatever the range is. This brought me back, this reference might date me, but this brought me back to my Nintendo DS. I definitely had this brain training game where it gave you different puzzles to play every day, and it told you what supposedly your brain age was, or your mental age in this case. And there's always like an optimal brain age, and your goal is to train your brain to get there. Brain training is kind of a whole separate myth that's been busted now. But when I saw mental age, that's what I thought about, that people are really trying to optimize their mental age. So let's just do a quick example and show you what this does. So let's take our first girl. If we're following this equation, and we put her mental age on top of the fraction, her chronological age on bottom, and multiply by 100, that would tell us that this girl would have a 125 IQ. And then just as another example, let's take the last girl, and she would have 100 IQ. So 100 is considered average. That's the middle of the overall kind of distribution of IQs, which we'll talk about in a second. And I don't care that you know how to do math on this. You don't need to solve math problems for this class, but I just want to show you that this is a simple kind of fraction that supposedly tells someone how intelligent you are based off, in this case, these two concepts, mental age and chronological age. Except there was a problem with this. This ratio IQ seems like a good little solution to figuring out someone's intelligence, but it doesn't work as well as it initially appears. So on these early tests, mental age kind of peaks at 16 years. So just like how the brain game said the optimal age is 20, in these kind of tests, the mental age peaked at 16. And that's kind of how you got, let's say you were 10 years old and you had similar abilities as a 16-year-old, you'd have 160 IQ, which is like Einstein levels, right? However, you're going to keep getting older. So this number on the bottom, your chronological age, is going to keep ticking up, which means, and just again, you don't need to know math, but this is how fractions work. As the bottom is getting bigger, that means this overall fraction is getting smaller. So it doesn't quite follow logically that just by getting older, your IQ decreases if your abilities stay the same, right? That's a little weird. So we had to do something to fix that. So now in modern kind of IQ scores, to solve this ratio problem, now we look at the deviation instead. So we look at scores that are relative. So instead of mental age and chronological age, now we're looking at your individual test score on our particular thing divided by the average test score of your peers. So now we're not constrained by any sort of age or what your mental ability age is. So we're not constrained by any sort of age here. So there's no cap or cutoff of what your mental age is, for instance, and you're not going to keep decreasing in the denominator as you get older. So yeah, this method has been a little bit more accurate at comparing different people's IQs. And I want to use comparing, I want to point that out because honestly, IQ is kind of really only important to compare people, to rank people, more than it is to actually tell you some internal thing about yourself. So it's more of a relative measure than it is a defining characteristic of you. So this is my little staying relevant meme. So instead of ratio IQs, deviation IQ is the better method to go with. So this is comparing your score to the average score of your peers, and it's still multiplied by 100 to make it a number that we like to look at. Okay, so let's return back to this distribution that we kind of hinted at earlier. So intelligence scores tend to kind of fall in this normal distribution. So let's do a quick jump back to our research methods. A normal distribution isn't just like a typical distribution. Normal has a specific meaning in psychology or in statistics. So a normal distribution is this symmetrical distribution where you know that about 68% or majority of your population is going to fall within one standard deviation of the mean. Your mean is here at the center. So majority of your people are kind of average or close to the center. And then as you kind of fan out to the extremes, the higher and lower end, there are a lot fewer people. So you'll see that there's only about 2% of the people who meet 3 standard deviations above or below the mean. And IQ score tends to map on pretty well to this normal distribution. So that center point, the 0 point, these are z-scores, so you don't need to know that. The center point represents an average IQ of 100. So this means that most individuals have 100 IQ, and majority of individuals, 68%, have IQs between 85 and 115. So this kind of represents the average IQ of the population. But you'll see that as you kind of fan out to the tails, about 2% of people get up to 145 to 160, and again, 2% of people get down below 70. So just to kind of play this out or give you another way of remembering this, again, the math kind of works out. I'm a math nerd, so I'm going to keep talking about fractions. But kind of one way to think about how this is a better ratio here is that, let's say your test score, an individual's test score, is below average. So you have a lower score than your peers. That means this fraction is going to be less than 1 because the bottom, or the top, is smaller than the bottom. So when you multiply that by 100, you're going to get an IQ that is less than 100. That's how we get everything on the left-hand side. And then conversely, in the same way, let's say you have an above average score. That's a fraction that's going to be greater than 1, which gives you a greater than 100 IQ. So this seems like a pretty straightforward fraction ratio way of getting to this distribution of IQ scores that we have. Again, I don't care that you can calculate math, but I think conceptually it's kind of cool to see where it comes from.